Hello everyone, welcome back to my YouTube channel. In this week video, I'm going to explain to you how you should answer quiz 4 questions. Altogether, we have 5 different questions and let's start with the first one. Question number 1. Determine the ionic strength of solution made by mixing 0.5 molar of sodium nitrate and 0.2 molar of calcium nitrate. Alright, in this question, we have two different components, which is 0.5 molar of sodium nitrate and the other one is 0.2 molar of calcium nitrate. So the first thing that you need to know is how to change it to the ionic form. So first we have 0.5 molar of sodium nitrate. Right? So it means that you are going to have sodium ion and also NO3 minus. So we're going to do the same with 0.2 molar of calcium nitrate. Okay, so we have the calcium and we have the nitrate. Okay, so in order for us to find the ionic strength is equivalent to half times the summation of the concentration times the charge on the ion square. Okay, now we're going to do one by one. So half times, we're going to start with this one first. So the concentration is 0.5. And then we're going to start with sodium. So this one is going to be positive 1 square plus the same concentration times this one. So it's going to be negative 1 square plus, right, now it's a little bit tricky. So you see here we have 2, right? So the concentration should be 2, but only for NO3. So here for calcium, because it only have 1 calcium here, so the concentration doesn't change. So it's going to be 0.2 times the calcium is positive 2. So positive 2 square plus, so for this one, because you have 2 here, so this 0.2 molar, you need to be 0.4. So why is 0.4 is 0.2 times 2, right? So times negative 1 square, right? So after you have calculated this, you should be able to get half times 2.2. Therefore, your ionic strength should be equivalent to 1.1 molar. So this is the final answer for the first question. Question number 2. Determine the enthalpy of reaction if the equilibrium constant at 2000 Kelvin and 3000 Kelvin are 0.782 and 8.614 respectively. Right, so this is a very straightforward question. So we just have to plug in the value inside the formula. So we are going to use the formula of ln K2 over K1 is equivalent to negative delta H divided by the gas constant times 1 over T2 minus 1 over T1. Right, so this is your T1 and this is your T2 and K1 and K2. So we're just going to plug in the value. So your K2 is 8.614 and then divide by the K1 0.782 is equivalent to your delta H, and the value of R that you want to use is 8.314, and the unit should be in joule per mole Kelvin. And then 1 over T2, your T2 is 3000 Kelvin, minus T1 is 2000 Kelvin. Right? So since we have Kelvin on two different places, so we can slash that out. So supposedly you will get 2.3993 is equivalent to negative delta H divided by 8.314 joule per mole, and here will be negative 1.6667 times 10 to the power of negative 4. So what's left here is for you to just calculate this by pressing your calculator. You will get your delta H is equivalent to 1.1968 times 10 to the power of 5, and the unit should be in joule per mole. Right, so this is the final answer for the second question. Right, continue on to question number 3. What is the pH of 0.2 molar of ammonia solution at equilibrium if the Kb value for ammonia is 1.8 times 10 to the power of negative 5, given that the reaction follows the following reaction? So they want you to calculate the pH. So given to you is already the balance equation here. So the first thing that you need to do is to write the ice diagram. So you just have to copy the equation given to you because it is a balance equation already. So we're going to do the ice diagram. Right, what is the pH of 0.2 molar ammonia? So initially, the concentration is 0.2. So remember, for ice diagram, water is not included. So at first, there will be no product form. So in order to produce the product, here needs to minus x. So here x and x. Therefore, you will get 0.2 minus x, x and x. Right. Given to you is the Kb, which is this value. So you know that your Kb is actually equivalent to concentration of x divided by 0.2 minus x. Right. So basically what we are going to do is we are going to use the approximation method. Alright, so in the approximation method, what we are going to do is we are going to remove the x here. So 1.8 times 10 to the power of negative 5. Since we have removed this x, so we're just going to 0 times 0.2. You bring this up here. So it's equivalent to x square. So your x square is equivalent to 3.6 times 10 to the power of negative 6. So you want to find your x, which is the square root of 3.6 times 10 to the power of negative 6. So you will get your x is equivalent to 1.8974 times 10 to the power of negative 3. Right. So since we are using approximation method, so we need to do the test. So the test is the value of x, 1.8974 times 10 to the power of negative 3 divided by the initial concentration. So the initial concentration is 0.2. So you need to times 100. So basically what you get is 0.9487%. Okay, this value is less than 5%. Therefore, the value of X that we have calculated in the beginning is approved. So you can use this value as is. Alright, so let us refer back to your ice diagram. So in your ice diagram, because you were asked to calculate the pH, right? Since this is a base, not an acid, so the thing that we can use is the value or the concentration of your OH minus. So apparently your OH minus is equivalent to X, so we can use this value of X. So since this is not an acid, so what we can calculate is your POH. So POH is equivalent to negative log OH. So negative log, the concentration of OH is 1.8974 times 10 to the power of negative 3. So you will get your POH is equivalent to 2.7218. So this is the POH, but you were asked to calculate the pH. So pH plus POH is equivalent to 14. So your pH is equivalent to 14 minus your POH, 2.7218. Therefore, your pH should be equivalent to 11.2782. So this is valid because this is ammonia solution. It's not an acid, it's a base. So definitely the pH should be more than 7. So this is the final answer for the third question. Let's move on to question number 4. Determine the concentration of hydroxonium ion in a 0.050 molar solution of barium hydroxide. Okay, in the question you were given the concentration of barium hydroxide. So in a way, you know that you already have the concentration of the OH, right? So POH is equivalent to negative log OH minus, right? So equivalent to negative log the concentration 0.050. So you will get your POH is equivalent to 1.3010. So the same drill, pH plus POH is equivalent to 14. So your pH is equivalent to 14 minus your POH, which is this value. So 14 minus 1.3010 should be equivalent to 12.6990. But in the question, you were asked to find what is the hydroxonium ion concentration. So you have to calculate again. pH is equivalent to negative log H3O plus. Right? So your pH is 12.6990 is equivalent to negative log concentration of hydroxonium. Therefore, your concentration of hydroxonium ion is equivalent to 12.6990. So you will get 1.9999 times 10 to the power of negative 13. Alright, so some of you might ask why we didn't do any ice diagram for this question. Right, so before you decide to do an ice diagram or you want to calculate directly like this, you need to look at the question. So in this question, you were given barium hydroxide. So this barium hydroxide is a strong base. So in a strong base, we consider that it will dissociate completely. So whatever the concentration of the strong base should be equivalent to the concentration of the OH. So that is why we can calculate directly like this without having to do the ice diagram. Moving on to the final question for this week's video. A student is studying the boiling point elevation of solution containing glucose dissolved in water. The student prepares the solution by dissolving 10 grams of glucose in 100 grams of water. The boiling point elevation constant Kb of the water is 0.512 Kelvin kilogram per mole. Determine the expected boiling point of glucose solution. Alright, so in this question, you were given the mass of the glucose. We have 10 grams of glucose. So, since we know the mass, we can calculate the number of mole. Number of mole is equivalent to mass over RMM. Right, so the mass is 10 gram. So now we are just going to calculate what is the RMM. So you have 6 carbon, so 6 times 12.0011, right? Plus you have 12 hydrogen, so 12 times 1.00784, plus you have 6 oxygen, it's going to be 15.999. So it's equivalent to 10 divided by 1.8015 times 10 to the power of 2. Hence, the number of mole is equivalent to 5.5509 times 10 to the power of -2 mole of glucose. So next up, what we are going to calculate is the molality. So molality is equivalent to the mole of solute, which is the glucose that we have calculated just now, divided by the mass of solvent. But remember, this mass of solvent should be in kilograms. So what is the mass of solvent? Your solvent is water, which is 100 gram. So the mole of solute, which is the glucose just now, is equivalent to 5.5509 times 10 to the power of -2. And then the mass of water, which is the solvent, is 100 grams. So you want to make it into kilograms, you need to divide by 1000. So you will get your molality should be equivalent to 0.5550 molar. Alright, so now you are going to calculate the boiling point elevation. So the boiling point elevation we can write as delta temperature boiling, which is equivalent to the elevation constant, the boiling point elevation constant, Kb, and then you have molality, and you have this I. Alright, so Kb is given to you 0.512 Kelvin kilogram per mole. Molality is the one that you just calculated, 0.5550 molar. Okay, so you end up with this. Right, since this is a glucose, so the value shall be 1. Therefore, you will get your boiling point elevation is equivalent to 0.2842. Okay, but the question asks you to determine the expected boiling point. So you want to know what is the new boiling point. So to find the new boiling point, you need to know what is the boiling point of water, because your solvent is water. Right, so naturally your boiling point of water is equivalent to 100 degrees Celsius. In the question, you were given the elevation constant is in Kelvin kilogram per mole here. So it means that this 100, you need to plus 273. So it's equivalent to 373. That is the actual boiling point in Kelvin, plus the elevation, which is 0.2842. So you should get 373.2842 Kelvin. So this is the new boiling point. Right, I'm just going to recap a little bit about this part because it's slightly different than in my notes, because in my notes usually I will give you the elevation constant is in degrees Celsius over molality. So this is actually almost the same. So your elevation constant is in Kelvin and then kilogram per mole, right? And then you times with the molality. So molality is actually mole per kilogram, right? So I'm just going to make it easier for you to understand. It's going to be Kelvin kilogram per mole. So mole, kilogram. So you will end up with Kelvin, right? Therefore, here the unit is in Kelvin. That is why here the unit is in Kelvin at the end. So for other question, you need to look at what is the unit given to you for the elevation constant. Alright, so this is the end of this week's video. I would like to thank all of you for watching this video from the beginning till the end. I hope this video will help you to understand more on how you should answer all the questions for Chapter 4 quiz. So I'll see you again next week. Thank you, take care and be good. Goodbye.